next, let us talk a little bit about the higher order derivative. Okay, suppose y equals to f of x is a function whose graph is given like this. Okay, so how do we denote the first derivative? The first derivative is denoted by f prime of x, right? Y prime or f prime of x, or sometimes we denote by dy over dx, right? These are the notation we use. This is or. So this is another notation. Okay, so how would the graph look like? Okay, so for the graph of f prime of x, look at this. The function is increasing left to 1. So left to 1, the graph must be above x-axis. You can think, okay, let's look at this. Left to 1, the graph of f prime must be above x-axis, because that must be positive. Why? Because left to 1, the function f is increasing. So, and also between 1 and 3, the graph is decreasing, meaning that you can have like this, right? Between 1 and 3, the graph is decreasing. Okay, and after 3, the graph is increasing, meaning that that must be above x-axis. This must be f prime, right? This is the graph of f prime of x. Okay, so the second derivative is basically the derivative of y prime. The second, so whatever you get in the derivative of y, that is y prime, you find out the derivative of that thing. Okay, so that we denote by y double prime, or you denote by f double prime of x, or you denote by d2y over dx square, or dx2. This is the notation for the second derivative. Okay, so the first derivative gives you slope or the velocity, but the second derivative gives you the rate of change in the first derivative. Okay, that is also called the acceleration. So the rate of change of the velocity, or the rate of change of the slope of the function, that is also called the acceleration. Second derivative gives you the acceleration. So if you are asked to find out the acceleration of an equation that represents the path or the position of the moving object, then you will have to find out the second derivative. Okay, so how would the graph of the second derivative look like in this case? So look at this. The graph is decreasing. Okay, the graph is decreasing left to 2. So it looks like this, right? So the second derivative must be below the x-axis, so it must be negative, right? The second derivative must be negative, and the graph is increasing up to 4, so the second derivative must be positive, right? And after 4, it is decreasing. So you can think of that type of graph for the second derivative, right, of fx. The second derivative means f double prime or y double prime, or d square d2y over dx2. You can think that way. Okay, guys. So how about the third derivative? What is the notation for the third derivative? You can denote by y triple prime or f triple prime of x, or d3y over dx 3. Okay, we don't use the graph of the third derivative and the higher order derivative than second derivative. Okay, so that much. So y iv or 4 primes, or fivx, or d4y over dx4. So that is the notation for the fourth derivative. Let us see some examples. Okay, let us see the example number 1 there. So y is given as 7 times x to the 1/2. Find y double prime. So let us find out first. We need to find out y prime, that is 7 times 1/2 times x to the 1/2 minus 1, because 7 is a number, so you can pull that out, and then you use the derivative of x to the 1/2. What is the formula? X to the n prime is n x n minus 1, right? Prime stands for the derivative. So if you simplify this, you will get 7 over 2, because 7 times 1/2 is 7 over 2, then times x to the negative 1/2. I'm not moving this to the down before I find out the second derivative. So let's find out the second derivative. So y double prime is the derivative of that thing. Okay, that will be 7/2 is a number, so you can pull that out, and then find the derivative of that x to the negative 1/2. That will be negative 1/2 times x to the negative 1/2 minus 1, right? Nx n minus 1. That will give you negative 7 over 4. Why? Because 7/2 times negative 1/2. will be 7 times negative 1 is negative 7, 2 times 2 is 4, times x to the negative 3 half. Now I don't want to keep the negative exponent, so what I want to do is negative 7 over 4x to the positive 3 half. You can write that way, or if you want to, you can write negative 7 over 4 and then square root of x cubed, because that 3 over 2 that goes to the square root, okay, because this is like x to the third times 1 half, that way. Okay, this is the final answer, or this is the final answer. So how about this one? For this problem, you have a quotient rule, right? It is like u over v, right? So what is the formula for u over the derivative of u over v? It will be f prime, the first derivative will be u prime v times v minus u times v prime over v square, right? So how that look like? It will be u prime is 1 times v is t minus 1 minus u is t times v prime. The derivative of t minus 1 is just 1, right? Divide by t minus 1 square. Let us simplify, okay, because you need to find out another derivative for this one. So it is basically t minus 1 times 1 is t minus 1 minus t divided by t minus 1 square. So if you cancel out those t, positive t and negative t, then what is left there is basically negative 1 over t minus 1 square. T minus 1 square. Now we need to find out the second derivative. Okay, how do I find out the another derivative? So f double prime, this is also a quotient rule, right? This is also a quotient rule. It is like u over v, right? But what is v? V is t minus 1 square. So what is t minus 1 square? T minus 1 square is basically t minus 1 times t minus 1, right? If you FOIL this, FOIL, you will get t square minus twice t plus 1. This is what you get. Okay, so how do I find out the derivative? Again, you use that formula, same formula, right? U is negative 1, so the derivative of u is 0 times v is t minus 1 square minus u is negative 1 times v is, what is v? V is t square minus twice t plus 1. You need to find out the derivative of v. So the derivative of t square is twice t, and minus derivative of twice t is 2 times 1 and then plus 0. That is the derivative of v prime, right? That is the v prime. So now we need to square the denominator, or square that one, v square. So that will be t minus 1 to the fourth, right? If you simplify that, what do you get? The first term is basically 0, right? And then the second term is basically, what you get there is a positive, negative times negative 1 is positive. So twice t minus 2. So twice t minus 2 divided by t minus 1 to the 4. But you can factor the 2 out, right? What is left is t minus 1 over t minus 1 to the 4. You see that? But you can cancel one of those, right? Because there is t minus 1. There are 4 of the t minus 1 multiplied together. So if you cancel one of those, then what is left is there is only 1 left there, right? That only 3 left. So that is 2 over t minus 1 to the third. That is the second derivative of this function. So basically, to find out the higher order derivative, you should start from the first derivative and then find out the second derivative and then find out the other derivative that you need. So you need to do turn by turn, okay? Let's